Swayam Prabha. Digital India. Educated India.
Now, we are going to discuss one numerical example to explain the working principle of this entropy based fuzzy clustering. Now, I am just going to take the same numerical example which I took for the previous algorithm, that is fuzzy Siemens algorithm. Now, once again let me take the same example. So, this example is nothing but the example of the free-form surface, and let me repeat. So, what I will have to do is, so this is the free-form surface, and this particular free-form surface I will have to generate, I will have to do the machining to get this type of the free-form surface. So, how to get it? Now, to carry out, so this particular machining with the help of milling cutters. So, before that what we do is, we do clustering based on similarity. Now, here we are going to discuss, so how to use this entropy based clustering to solve this clustering problem, or how to achieve the suitable clusters. Now, let us take the same example, and here, so what I am going to do is, the same set of 10 points we are going to consider, and which are lying on that free-form surface, and let me do this particular clustering using entropy based clustering. Now, these data points are nothing but the 3D data points, that means corresponding to the first point. So, I have got x dimension, y dimension and z dimension. Similarly, we have got 10 number of data points. Now, in fact, if I want to do the optimization for the practical problem related to the machining of free-form surface, so we will have to take a very large number of data points, might be 10,000, 20,000 data points, but here for simplicity I am just going to consider only 10 data points, and for each of the data points, so I have got 3 dimension. So, in the matrix form, so this particular data can be represented by your 10 cross 3 matrix. There are 10 rows and 3 columns. Now, here I am just going to carry out the fuzzy clustering based on similarity and entropy, and we assume that the threshold value for this particular the similarity, that is beta, is nothing but 0.05, and to determine whether there is any such outlier, we consider the concept of gamma, and we assume that gamma is equals to 10%. Now, here, so let us see like how to use this particular concept to solve the clustering problem. Now, the first thing we do is, we try to find out the Euclidean distance between the two data points I and j. So, this formula I have already discussed. So, d I j is nothing but square root of summation k equals to 1 to L x I k minus x j k square, and here we are going to consider actually the 10 data points, that is n is equals to 10. Now, so using this actually we can find out what should be d bar and all such things, because here, so 10 C 2, that is nothing but is your n C 2. So, n C 2 is actually the total number of the distance values which we will have to consider and calculate, and here it is nothing but is your 10 C 2, and that is nothing but is your 10 factorial divided by 8 factorial and 2 factorial. So, it is 9 multiplied by 10, 90 divided by 2. So, I have got actually the 45 distance values, and here d j I is nothing but d I j, and the diagonal elements are all put equals to 0, because d 0 0 d 1 1 is nothing but equal to 0. So, using this particular information, so very easily you can find out what is your d bar, that is your the mean distance, that is d bar, and once you have got this particular d bar, that is summation d I j divided by 45 is something like this 0.518373. And once you have got this particular d bar, so very easily I can find out. So, this alpha is nothing but ln 2 divided by is your d bar, and if I calculate for this particular data point, so this will become equal to 1.337160. And once you have got this particular value for the alpha, now we are in a position to calculate what should be the similarity, that is S I j, and that is nothing but e raised to the power minus alpha d I j, and alpha is equal to 1.337160. Now, if I just calculate what should be the Euclidean distance value and what should be the similarity, now we can find out. So, there are 10 points. So, the way I am marking, the first point is marked as 0, the second point is marked as 1, similarly, the 10th point is marked as 9. So, what we do is we try to find out, we try to first determine the Euclidean distance between 0 and 1, that is nothing but d 01. So, this is nothing but is your d I j, and this is nothing but the similarity, that is S I j. So, what we do is the distance between 0 and 1 we try to calculate the way I have already discussed, and once we got that particular distance value and knowing the value of alpha. So, we can also find out what is the similarity. Now, similarly, the Euclidean distance and similarity for the different data sets, for example, say different data combinations like 0 and 2, 0 and 3, 0 4, 0 5, 0 6, 0 7, 0 8 and 0 9 we can find out. So, for different combinations of these data points starting from 0, so I can find out the Euclidean distance values and I can find out their similarities, exactly the same way the way I have already discussed. Now, the next is I will have to find out the distance and your similarity values. So, this is nothing but d I j and this is your S I j, and I can find out the distance and similarity between 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6, 1 and 7, 1 and 8 and 1 and 9. Now, this 1 0 I should not determine, because I have already calculated 0 1 and the distance between 0 1, that is your d 01 is nothing but d 10, and we consider similarity between 0 1 is nothing but similarity 10. So, starting from 1, so 1 to 1 3 and so on up to 1 9, I can find out the distance and your the similarity values. Now, by following the same procedure, so I can also find out your the Euclidean distance, that is d I j, and the similarity, that is S I j between 2 and 3, 2 and 4, 2 and 5, 2 and 6, 2 and 7, 2 and 8, 2 and 9. Now, here I should not determine 2 and 0, because I have already determined 0 2, then 2 and 1, because I have already considered 1 2. So, I can find out the Euclidean distance and the similarity. Similarly, starting from 3, so I can find out between 3 and 4, 3 and 5, 3 and 6, 3 and 7, 3 and 8 and 3 and 9. So, using this particular method, so I can find out. Then between 4 and 5, I can find out the distance and similarity. Then 4 and 6, 4 and 7, 4 and 8 and 4 and 9. Other things I have already considered. Then between 5 and 6, 5 and 7, 5 and 8, 5 and 9. Then comes between 6 and 7, 6 and 8, 6 and 9, 7 and 8, 7 and 9 and 8 and 9. So, I can find out the Euclidean distance and your the similarity. Now, for the different combinations of the data points, we have already calculated their Euclidean distance values and the similarity values. Now, we are going to use this particular information to find out what should be the entropy, the total entropy for each of the data points. So, here we have considered there are 10 points, that means starting from E naught, I will have to find out E 9. Now, let us see how to find out. So, the first one, that is E naught. So, E naught is nothing but is your, so this E naught is nothing but, so I am just going to use this particular expression. Here I equals to naught and j varies from what? J belongs to x. So, if it is I equals to your 0 and j is not equals to I. So, I will have to start from 1 and I will have to go up to 9. So, what I will have to do is, so I will have to find out here minus. So, is I equals to 0 and let me put j equals to 1, then log base 2, then is 0 1 plus 1 minus. So, is I j. So, this is nothing but is 0 1, then come your log base 2. So, 1 minus. So, is then I is equals to 0 and this is nothing but 1. And here actually this should be your minus, because minus is outside. So, if I write separately here, that will be minus. Then I will have to write down and j equals to 2. So, this will become minus is 0 2 log base 2 is 0 2 minus 1 minus is 0 2, then comes log base 2, then comes 1 minus is 0 2, and this I will have to write, and the last term will be as follows is 0 9, then comes your log base 2, then is 0 9, okay, minus 1 minus is 0 9 log base 2, then comes 1 minus is 0 9. And if I just calculate, then I will be getting, so E naught is equal to your 8.285456, the way I have written it here. So, this is the way actually you can find out what should be the total entropy of a particular the point. And similarly, yes. So, there is one small mistake. So, these are to be added. So, in fact, this is not equal. So, all such things I will have to actually go on adding or go on subtracting. Then finally, you will be getting this particular the expression. So, this should be this equal sign should be replaced and there should be negative sign, because this is a summation. Now, so following this method, so I will be getting this particular E naught, and similarly actually we can also find out what is E 1, what is E 2, and then comes your E 3. So, using this actually I can find out what should be the entropy values for the different data points. Now, as I told, following the same procedure, so I can find out what should be your E 4, then E 5, E 6, E 7, E 8 and E 9. Now, if I compare, so all the entropy values, now if you see the entropy values like E naught, E 1, E 2, E 3 and your 4, E 5, E 6, E 7, E 8 and E 9, the minimum in terms of the numerical value, the minimum will be your E naught. That means, your the first point will be selected as the first cluster center. That means, your the first cluster center will be the first point, because the 0th point, that is the first point, is nothing but the first cluster center. And let me assume that the threshold value for the similarity, that is beta is equals to 0.5. Now, if you just go back on the picture of the similarity, so I can find out the first cluster. For example, say the 0 has been taken or has been considered as the first cluster center, and now I will have to find out the similarity between 0 and 1, 0 and 2 up to 0 and 9, and if I concentrate on these particular similarity values and beta, the threshold value of similarity is 0.5. So, I will have to identify those points whose similarity with the cluster center, that is 0, is greater than or equals to 0.5. Now, here if you see the similarity is your 0.669551. So, this is very similar to your the first cluster center. So, this should be considered in the first cluster. The second one is 0.424773, that is less than 0.5. So, this should not be considered. The third point should not be considered. The fourth one should be considered in the first cluster. The fifth one should be considered, but sixth one should not be considered. Seventh one should be considered, eighth one should be considered, but ninth one should not be considered in the first cluster. And the same thing actually I have just put it here. So, you can see that in the first cluster, so we have considered the first point, that is the 0th point, is nothing but the cluster center, and the other points will be the first point, fourth point, fifth, sixth and the eighth point. Now, if 0th is the first point, so truly speaking this is the second, fifth, sixth, eighth and ninth point. And this is the way actually we will have to form this particular the cluster. Now, once you have got this particular cluster, so out of the 10 points, a few points have been considered, but we have got a few remaining points. What are those remaining points? The remaining points are nothing but second, third, sixth and ninth, and out of these the E values if you consider, that is your E2, E3, E6 and E9 if you compare. So, this E6 is found to be the minimum. So, the sixth point will be considered as the second cluster center, and once you have considered the sixth point as the second cluster center, once again you see the similarity of the other points like second, third and ninth with the sixth, and those similarity values we have already considered. So, what we do is we consider at the center, that is nothing but the sixth point, and surrounding that. So, we have got a points like the second point, then comes the third point, then comes the ninth point in this particular the cluster. Now, till now actually whatever we have discussed. So, we have got two clusters, and if I just draw it, so might be this is my the first cluster and this is my actually the second cluster, and the clusters are fuzzy in nature. So, there could be some overlapping region also. Now, here so 0th is the first cluster center, and that is followed by the first, then fourth, fifth, seventh and eighth points, and here in the second cluster the sixth is actually the cluster center, and here the second, third and ninth will be your the data points which are going to follow your the sixth, that is the second cluster center. So, this is the way actually we will be getting two such fuzzy cluster using your entropy based clustering. Now, if you see here the number and nature or the quality of the clusters depends on actually a number of parameters. In entropy based fuzzy clustering, we have considered a few parameters. For example, say we have got alpha that relates the relationship between your the Euclidean distance and similarity. Then comes we have got beta, that is the threshold value of similarity. Then comes we have got gamma, which decides your the outliers. So, performance depends on this particular alpha, beta and gamma, and we have seen that. So, this particular clustering algorithm is very flexible, and we can yield the distinct clusters here, but the compactness will be less. Now, this algorithm is also very fast and you will be getting the distinct clusters, but as I told we may not get very compact, and that is why actually we try to combine the merits of fuzzy Siemens algorithm and the merits of this entropy based clustering algorithm. So, just to develop the entropy based fuzzy Siemens clustering. Actually, this entropy based fuzzy Siemens clustering has been proposed by us, and where we tried to consider the merits of these two algorithms, and we try to eliminate their inherent demerits. Now, let me repeat what we need. We need the clusters should be very distinct, and we need actually the clusters should be very compact, and at the same time the number of outliers should be as minimum as possible. So, we formulated as an optimization problem, and we solved using one nature inspired optimization tool, so genetic algorithm, which I am not going to discuss in details in this course. Now, here with the help of that, so we could find out very distinct, very compact, and the number of outliers will become minimum. So, that type of ideal clusters we could get. And moreover, another experience which I am going to share with you people, the performance of clustering algorithms are found to be data dependent. So, for different data sets, the performance for the clustering algorithm could be different, and actually it depends on the nature of this particular the data sets. Now, the references, the textbook for this particular course, that is the textbook Soft Computing Fundamentals and Applications written by me. So, you will be getting the material which I discussed. You can also consult the book Fuzzy Sets and Fuzzy Logic Theory and Application by George Clear, and for the combined that entropy based fuzzy clustering, if you want to have a look. So, you will have to look into this paper written by us, like genetic algorithm tuned entropy based fuzzy Siemens clustering for obtaining a distinct and compact cluster. Now, here I just want to tell you that in this course I am not going to discuss the principle of nature inspired optimization tool or the genetic algorithm in details. Actually, that working principle of genetic algorithm and other nature inspired optimization tools has been discussed in much more details in another MOOC program, another MOOC course, that is called traditional and non-traditional optimization tools developed by me, and this is also available in details in your textbook, that is Soft Computing Fundamentals and Applications by D.K. Pratyahar. So, you can have a look of these books. Now, let me conclude whatever I discussed. So, here we try to concentrate on the various applications of fuzzy sets. Now, as I told that if you see the literature, the fuzzy set has been used to solve a variety of problems. Now, out of all such problems, two problems I have discussed in details, like how to develop, design and develop the fuzzy reasoning tool in the form of fuzzy logic controller, so that we can establish the input output relationship. So, to establish the input output relationship, we can take the help of fuzzy reasoning tool or your fuzzy logic controller. And the principle of fuzzy reasoning tool, like your Mamdani approach, then comes Takagi and Sugano's approach, we have discussed in details with the help of suitable numerical examples. Now, after that we started with fuzzy clustering, two very popular tools for fuzzy clustering. One is the fuzzy Siemens clustering, another is your entropy based fuzzy clusterings have been discussed in details with the help of some numerical examples. Thank you.